All right, this is Math 101, chapter 10.1 on Cartesian coordinates. So we're going to be learning how to graph linear equations, but before we do that, we have to go through what the coordinate plane looks like. So here we've got a grid, a Cartesian plane that is made up of two axes. And so we have a horizontal axis, which is the x-axis, and we have a vertical, which is the y-axis. And so everything about this is all about location. It's a address of a point that's given two coordinates, and we put those in an ordered pair, which we call the XY ordered pair. So I think of it alphabetically because X comes first, Y comes second in the alphabet. So X comes first and Y comes second in the ordered pair. And the beginning part, or the starting part of our address, is what we call the origin, and that is the 0, 0 point. Okay, so that is what we call the origin. And you'll see that these axes divide the coordinate plane into four what we call quadrants. And so the first quadrant is in the upper right-hand corner, and we use Roman numerals to denote the quadrant, and that is quadrant 1, and everything in quadrant 1 is going to be a positive point. So I'm going to shade everything in this upper right-hand corner is in quadrant 1, okay? Then we go to quadrant 2, which is right here. We go counterclockwise. Quadrant 2 is everything in this upper left-hand corner of our graph. And then we go to quadrant 3, which is the lower left, and quadrant 3 is down here. And last but not least, we have quadrant 4. And quadrant 4 is going to be in the lower right-hand corner. So we have signs that are positive, we go in the right direction. Negative, we go in the left direction on the x-axis. Positive, we go in the up direction. And left, we go in, down we go in the negative direction. So in quadrant 1, we have two positive coordinates. In quadrant 2, we have a negative x and a positive y. Quadrant 3, we have negative x's and negative y's. And then in quadrant 4, we have positive x's and negative y's. Now, a point cannot be in two quadrants at once. So you're either in a quadrant or you're on an axis, okay? So if a point sits on an x or y axis, it is not in a quadrant. And just remember that the quadrants go counterclockwise, okay? So starting in the upper right, we go in the left around the clock direction, counterclockwise, okay? So when we are giving points and we are trying to plot points, you will look at this point. Usually capital letters are what denote the point. You will, if we have -3, I will move 3 in the left direction because that's negative, and then I will move 2 in the right direction. And so when I go -3, here's -1, -2, -3. And from that point, I will go up +1, +2, and that is my location for A. And I just put that, so it's basically the intersection of where it hits on the y-axis and where it hits on the x-axis. So I just kind of go in the x direction first and go in the y direction from that point, and then you will have that location. And so this is in what we call quadrant 2, okay? Then if I'm going to plot -1, so I'm going to go this way, and -4, I'm going to go 1, 2, 3, 4, and there is my point B. And this is in quadrant 3. So I'll put that over here, quadrant 3. Actually erase this. Okay. All right, so now for C, I am going to go 3 to the right, 1, 2, 3, and then I'm going to go down 1. Whoops, that's the wrong point. Which is at right here. And that is C. And that is in quadrant 4. All right, the next point is point D. So I go 3 to the right, and I go 1, 2, 3 up. That is point D, which is in quadrant 1. Okay, now the next 2 points are actually points that sit on an axis. So remember here, I'm going to draw a line over here. The point 0 goes nowhere in the x direction, and then it will go 4 units up. So that is going to be 0 in the x, so I'm going to go 1, 1, 2, 3, 4. Here is my point, and that is E. And so this is on the y-axis. It is not in a quadrant. Okay? And then the next one is going to be on the x-axis. So the next one we're going to go -5. So this is going to go 5 in the left direction. 1, 2, 3, 4, 5. And it's going to go nowhere in the up direction. So that would be the point F. And this is on the x-axis. So you need to be able to plot your points on an axis, and also plot the points in in your Cartesian plane, and then be able to tell whether it's in a quadrant or on an axis. Okay. The next thing that they'll do is they'll ask you to give locations for each of these points. And so again, however is easiest for you. I'm also going to put the quadrant. So I'm going to list the points here: A, B, C, D, and E. Okay. And A is at -4 on the x-axis, and then it is at it is at +4 on the y. And then if we wanted to, we would say that is in quadrant 2. Okay. All right. B is at -3 on the x-axis and -4 on the y-axis. So again, if you plot here and here, that is the location. And that is in quadrant 3. All right, C is 0 on the x, because we do not move in any direction left or right, and it is at -4 on the y. So if I just it's hard to see on these lines, and this is on the y-axis. And D is also on the y-axis. It goes 0 on the x, but it goes 3 on the y. And then E goes 4 on the x and 1 on the y. And that is in quadrant 1. Okay. All right, so now we're going to do the next one. Over here, I'm just going to go ahead and M, N, O, P, and Q. M is the point -3 on the x, 1 on the y, and I'm just going to put Q for quadrant 2. N is -1 on the x and 5 on the y, and that is also quadrant 2. O is 0 on the x and 3 on the y. That is the y-axis. P is 1 on the x and 5 on the y, and that is quadrant 1. And Q is 3 on the x and -2 on the y, and that is quadrant 4. Okay, so we have to be able to plot points before we can graph a line. So knowing how to find locations and also plot locations is going to be the first part of this chapter. Now, to determine whether an ordered pair is a solution, you basically are substituting in your x value and your y value into this equation, and then seeing if it equals what it says it equals, okay? So if I'm going to take 3, replace the parentheses for x, subtract the y, and I want to see, does that equal 12? When x is 0 and y is 12. And so we get 0 minus 12, and that does not, because -12 does not equal 12, so we would say no, not a solution. And these are just going to be yes and no questions in your Hawks, so it's just a click a yes or click a no, okay? All right, then we're going to do another one, same equation, different point. So 3 parentheses for x minus parentheses for y, and we want to say, does that equal 12? So x, and I always label it underneath, x is 1, y is -9. So the reason I like to do parentheses is so that I don't lose a sign, especially when it's a subtraction, because now I get 3 and minus a -9 is +9, and 3 plus 9 does equal 12, so we would say yes, a solution. So what does that mean? It means that point, 1, -9, is on the line when I graph it, okay? All right, so we're going to try these 3 points for this equation. So I write x and y, and then I come over here, x plus 3 times y, and I want to see, does that equal 6 when x is 3 and y is 1? And 3 plus 3 does equal 6, so this would be a yes. Then we go the next equation. Again, we use the same equation, but we're using a different point. And so this time x is 6 and y is 0. So we put 6 in for x and 0 in for y, and 6 plus 0 does equal 6, so this would also be a yes. And then the last point, x is -2, y is 2/3, so parentheses for x plus 3 parentheses for y, does that equal 6? So x is -2 and y is 2/3. And so when I multiply 3 times 2/3, I now have -2 plus 2, and that does not equal 6. So that would be a no. Okay. Now we're going to be completing the missing coordinates of an ordered pair. So they will give you either an x or a y value. and then you will have to substitute in for that equation, to find the missing point. You're going to substitute the point that you're given and then solve the point that you are looking for. So sometimes I think it's a little bit easier when you solve these equations for y. So I'm going to go ahead and do that. I'm going to practice solving these equations for y. And so sometimes that makes it a little bit easier. Sometimes it doesn't, but it's just really up to you. It's always a good practice of doing this. So let me show you. If I do this, solve for y. So I have 5x. I'm going to just do this. 5x plus 3y is equal to 15. So I'm going to subtract 5x. So now I get 3y is equal to negative 5x plus 15. And then I'm going to divide by 3. And so y is equal to negative 5/3 x plus 5. Okay, so that makes it a little bit easier, and I'm going to write that up here. Y is equal to negative 5/3 x plus 5. So now we have an x value of 0. So y is negative 5/3 times 0 plus 5. And so that goes away. And that tells me that the y value is 5. Okay. Now, this one is a little bit tricky because, I don't get a nice x that's going to cancel, but that's all right. So now I'm going to go y is negative 5/3 times 2 plus 5, which is equal to negative 10/3 plus 5. And so let's make this into a fraction. So now we get negative 10/3 plus 15/3, which is 5/3. And that would go here. Okay. All right, so now we're going to be finding x. And so when we're given this equation, I'm going to come down here. Okay, I'm looking for x, but I'm given y. So now I've got 0 for y, negative 5/3 times x plus 5. And when I solve it, I'm going to subtract 5. So now I get negative 5 is equal to, equal to negative 5/3 x. And in order to solve that, I'm going to multiply by negative 3/5 because that's the reciprocal. So that cancels and leaves x. And those 5s cancel. And I get negative 3 times negative 1, which is positive 3. All right, I do the same thing for this one. I'm going to have to do a little bit of work here. So this time I'm given 4, that's y, is equal to negative 5/3 x plus 5. I subtract 5, and I get negative 1 is equal to negative 5/3 x. And then I still multiply by the reciprocal, negative 3/5. And so the negative and negative cancel, and I get 3/5, and that makes x. So 3/5 is your other part of the ordered pair. Now, it's kind of a coincidence that the B was 5/3 and D was 3/5. That's just kind of a fluke because some students ask me that. And it's really just a matter of, what's easiest for you. If you don't want to solve for y, you don't have to, but I really think it's a lot easier when you solve for y because it makes a little bit less calculations when you're doing the equations. So that's what I'm going to do. I'm going to go ahead and I am going to subtract 3x. And so now I get negative 4y is equal to negative 3x plus 7. This one might not be a good one to do. And I'm going to divide everything by negative 4. So y is equal to negative 3 divided by negative 4 makes that a positive 3/4 x, and then minus 7/4. Okay? So for A, x is 0, so 3/4 times 0 makes 0, and so I get negative 7/4. Now, it's not uncommon to have fractions in our linear equations, because that fraction we will eventually see is going to lead us into what we call slope, which is going to be, I think, 10.3 when we get to that section. Okay. All right. For B, now we have y, and we're looking for y when x is 1. So 3/4 times 1 minus 7/4. Well, that's good because they have the same denominator. So 3/4 minus 7/4 is negative 4/4, which makes negative 1. Okay. Then we go to C. Now we have y, which is 0, is equal to 3/4 x minus 7/4. We're going to add 7/4. And so 7/4 is equal to 3/4 x. And then we're going to multiply by 4/3. And so the 4's are going to cancel. These are going to cancel. And so x is 7/3. Oh, now this is just not nice. We got a fraction. So we're going to have y is 1/2. So let's use this color. Let's do this one. So y is 1/2 is equal to 3/4 x minus 7/4. We're going to add 7/4, which means that I'm going to have to change this to, oops, I'm running out of room. Let's come down here. That's going to be 2/4 plus 7/4, which is 9/4, and that equals 3/4 x. So we multiply by 4/3. Those cancel and leaves x. The 4's cancel and leaves 9/3, which simplifies to 3. So all that work, and we get a nice, nice number. Okay. So now they're going to present these to you in different forms. One, they're going to have a blank with an ordered pair where you're going to have to find the missing point. The other way is they're going to have a table where you're going to have to complete the table. Okay. So this is the same idea as this. You have 0 and you're looking for that blank. My iPad's going funky here. So it's the same idea. We've got the point 0 and we're looking for that coordinate. Here is your equation that you're going to use for all of these points. So I'm just going to label them as 1, 2, 3, and 4. And then I'm going to come down here and I'm going to show my work. Okay. So 1, I have the x value. So y is 2 times the x, which is 0. And so that goes away. And that tells me that my y for that point is -3. Then since I'm in the y mode, I'm going to jump down to number 3, okay, because these two are looking for y's. So number 3 says y is equal to 2 times x, which is negative 2, minus 3. And so now I have negative 4 minus 3, and that point is negative 7. And then I'm going to switch modes here, and now I'm going to do number 2 and number 4. So number 2, I'm given my y value of negative 1, and I'm looking at 2 times x minus 3. And I solve by adding 3. And so that gives me 2 is equal to 2x, and I divide by 2, and so x is 1. And then I do the same thing for number 4. So this time y is 3, and 2x minus 3. I'm going to add 3. And so now I get 2x is equal to 6. I divide by 2, and x is 3. And that's how we would complete the chart, okay? Like I said, when you get linear equations, it is not uncommon to have a fraction in front of the x, as we will see eventually when we do slope, okay? So I'm going to label these again. I'm going to do this as 1, this is 2, this is 3, this is 4, and I'm going to go ahead and do my 1 first, where y is equal to 3/4 times 0 plus 2. Well, anything times 0 goes away, and so that is 2. I'm going to jump down to number 3. Y is 3/4 times the x, which is negative 4, plus 2. So then what happens here, these cancel, and that makes negative 1. And negative 1 times 3 is negative 3, plus 2, which is negative 1. All right, I'm going to switch modes here and now go looking for the x values. So in number 2, y is 5, 3/4 x plus 2. Let's subtract 2. So that gives me 3 is equal to 3/4 x. And then I will multiply by 4/3. Those cancel and leave me x. The 3's cancel and leaves me 4. And then last but not least, number 4, we get 5/4 is y equal to 3/4 x plus 2. And so let's go ahead and write 2 in terms of 4s. 2 over 1 becomes 4. Oh, wait, I want 4s, sorry. Two over 1, and we want to change that to 4s, which becomes 8/4. So I'm going to subtract 8/4. Subtract 8/4. So that goes away. 5 minus 8 is negative 3/4 is equal to 3/4 x. And when I multiply by 4/3. I'm going to get x is negative 1. Okay? So, again, it's up to you if you want to solve for y or not, because that second equation in the next example is not going to be solving for y. or it's not set up that way. And I'll let you choose. So I'm going to show you a different way to do that one. But for the next one, you should be able to do. So we're going to go here. Again, I'm just going to label these. Okay, here's my equation. So I'm going to do number 1 first. Y is equal to 3 times 0 plus 5, which is 5. 3, y is equal to 3 times negative 2 plus 5, which is negative 6 plus 5, which is negative 1. Oops. All right, then we're going to go for the x's. So in number 2, y is negative 4 equal to 3x plus 5. Subtract 5. Negative 9 is equal to 3x. Divide by 3. X is negative 3. And then the last one, number 4, y is 2 is equal to 3x plus 5. Subtract 5. That gives me negative 3 is equal to 3x. Divide by 3. X is negative 1. Now, I'll leave this one up to you. You can substitute as it is. So I'm going to show you how to do that. I'm still going to label these as 1, 2, 3, and 4. So in equation 1, I have 4 times 0 plus 3y equals 6. So now I've got 3y equals 6. Divide by 3. Y is 2. Okay, go to number 3. I've got 4 times x plus 3y is equal to 6. So that becomes 12 plus 3y is equal to 6. Subtract 12. 3y is equal to negative 6. Divide by 3. And y is negative 2. Okay. All right. Now, if I do the next ones, I'm going to do number 2. Okay. 4x plus 3 times 0 for y is equal to 6. Well, that goes away. So 4x equals 6. Divide by 4. X is equal to 3 halves. Now, I believe you guys can put these in as decimals, but it's really a good idea to keep them in fraction form. That's usually what Hawks wants rather than decimals. So number 4, I get 4x plus 3 times negative 1 is equal to 6. 4x, minus 3 is equal to 6. I'm going to add 3. So I get 4x is equal to 9. Divide by 4. And so x is 9/4. Now, I would not have you plot a point of 9/4, but you should be able to solve those equations, okay? The last thing that we're going to do is do kind of an introduction to an application problem where they give you the volume of a box where the height is going to be changing, okay? And so we're going to basically just substitute these in. The h value is given to us so that we can find the volume, okay? So basically what we're going to do is we're going to say, okay, for the first one, we want to find the volume when the height is 4, and so that would be the volume is 24. We want to find the volume when the height is 5, that would be 30. Find the volume when the height is 9, that would be 54. and find the volume when the height is 10, and that would be 60. And so essentially you've got some ordered pairs here. You've got 4, which is the height or the x value, and you've got the volume 24, which is the y value. So when you plot it, you're going to come down here on the height or the x-axis, and you're going to find the number 4, and then you're going to plot the point at 24 on the y. And then we go 5 goes to 30, and 9 goes to 54, and then 10 goes to 60. And so essentially you're going to, let's say 4, 5, whoops, I plotted that on the wrong point. I was going to say it looks a little funny here. This point, I was at 8, so there we go. All right, so 9 should be here. All right, and then you would connect your line, and that's why we call it a linear equation. All right, so that finishes up 10.1 in the Hawks section.